Okay, so let's read the question carefully. It says PQRS is a rectangle. That means all of these angles here are 90. And it says triangle PTQ. PTQ is an isosceles right angle. So this is the same, and this is also 90 degrees. And they tell us that PQ has a length of 4. So this is 4. Okay, and this is isosceles right angle. So the basic isosceles right angle triangle has, we can say, well, this is, if these two are 1, this would be root 2. So the ratio between these numbers is root 2 over 1. So this length right here will be just 4 divided by root 2, which is going to be 2 times 2 divided by root 2. It's going to be 2 root 2. Okay, it's 2 root 2. Okay, so hopefully I didn't rush the root calculation there. So this is 2 root 2. And QR is equal to 3. So this is equal to 3. The area of PTR, so let's highlight that. PTR. What is this area right here? Other length we actually know is, because this is 3 and 4, and it's a right angle triangle, this PR is going to be 5. So 3, 4, 5 is a Pythagorean triple. Okay, so the general approach here would be to find these two triangles separately, the entire thing, and subtract some of these parts. What I'm going to do is, for this question, find these two triangles area separately. Now, if I drew this line right here, okay, this line right here, because this is 90, this right here was, this is completely symmetric, this is 90, this is going to be 45, so we have another 90, 45, 45 triangle, which will make this length here 2. Okay, which will make that length 2. Makes down here 2 as well. We call this little height here h, because I would like to find out what that h is. And let me call this one here, it's a little bit, it seems a little bit bigger, so let's call that big H. And because actually this triangle here and this triangle here is similar, we can actually say the big H over small h has to equal to the same ratio as 3 over 2. Okay, let's just keep that in mind. Okay, what we like to do to find the area is the following. Find the area of triangle of PQR and subtract, okay, this small triangle on the top. Let's call this here A. Okay, so triangle of AQR, and we're gonna add, okay, the area, the triangle of ATP. ATP. Okay, so PQR, right? So that's gonna be very easy. 3 times 4 divided by 2. Okay. AQR is, okay, let's just write it out in terms of the big H. So it's going to be 3 times by the big H divided by 2. ATP, right, is going to be 2 plus the small h times by 2, the height, over 2. Okay, so we get 6 minus 3 over 2 big H, and just 2 plus small h. So you get 8 minus 3 over 2 big H plus small h. The other obvious fact that I didn't state here is that big H plus small h is equal to actually 2, right? It just adds up to 2. And the big H, right, the big H is 3 over 2 small h. So 3 over 2 small h. So from here we can actually solve for the small h. This is going to be 5 over 2 small h is equal to 2. So h is equal to 4 over 5. Great. 8 minus, this is 4 over 5. And the big H, right, the big H is going to be 3 over 2. So 3 over 2 times another 3 over 2, 4 over 5. So you get 8, these two cancels out. We have minus 9 over 5 plus 4 over 5. You get 8 minus 1, right? This is 5 over 5, so the area is equal to 7.